All living life forms depend on the environment and on other organisms for their survival, and the world offers a vast assortment of conditions for organisms, each unique and ideal to its organism's need. Territories of the Earth that has comparative conditions like comparable atmospheres and comparable living organisms are called biomes. These biomes are then classified into zones depending on their distribution or course of action in living space or controlled by natural variables. This classification is called zonation. Moreover, all life forms have essential demands for survival, which causes dependency on the living and non-living features of the Earth. These living features are known as the biotic factors, while the non-living features are the abiotic factors. Additionally, a biome can have several interactions or connections of living and non-living things in an environment as a unit. This is called ecosystems. Barnacles, Cirripedia, are crustaceans from the family of Tecostraca and phylum Arthropoda. Barnacles are mostly found in the sublittoral zone 75% and middle level of intertidal zone 25% of the rocky shore. The circulation of this current species population is affected by numerous factors, for example, wave action, food sources, and relationship with different species. In addition, barnacles have profoundly created adjustments for survival to an assortment of natural environmental changes. Furthermore, Cirripedia feeds on suspended particles in the water through its finger-like appendages called cirri. Additionally, they use these appendages to get oxygen from the water. Every living organism assumes a significant job in an ecosystem, accounting for its lifestyle. This is known as a niche. A niche is controlled by resistance limitation of organisms or limiting factors, which is any biotic or abiotic factor that limits the presence of life forms in particular situation environment. In the intertidal zone, barnacles are essential in the ecosystem. The distribution of barnacles population, wave activity, and drying up are viewed as the most critical constraining components. Another constraining component is temperature. The metabolic rates of organisms and the general profitability of biological systems are straightforwardly directed by temperature. Barnacles are living organisms influenced by changes in the temperature of their environment. Diedrich also reported that as the temperature increases from 10 degrees Celsius to 15 degrees Celsius, encouraging rate of barnacles will likewise increase. Still, the presence of barnacles outside the temperature range is not unlikely since barnacles are considered as one of the most heat-tolerant organisms in the rocky shore. Another abiotic factor is pH levels. Barnacles can survive low or very high pH levels, but their optimum acidity condition is of the pH levels of 4.0 to 6.5. pH level can affect morphological trait of a barnacle. Reduced pH would result to larger barnacles. Low levels of pH can increase the size of the calciate crystal which comprise a barnacle shell. However, their base plates crack more readily. Therefore, there is lesser number of barnacles in areas of low pH level. Finally, Cirripedia's relationship with different species, interspecific rivals as well as predations, has likewise fundamentally influenced the circulation of their populace. Gauss's law of competitive exclusion expresses that in competition between species that seek the same ecological niche, one species survives while the other one expires under a given set of environmental conditions. Their primary predators are fishes, crabs, humans, and whales, while limpets compete with them for algae. If barnacles are in fact affected by environmental conditions, how can temperature, dissolved oxygen concentration, pH level, competition, and food source affect the distribution of barnacles population in the rocky shore? Considering that Cirripedia is one of the dominant members of rocky shore communities, temperature, dissolved oxygen concentration, pH levels, competition, and food source influence the distribution of barnacles populace in the rocky shore by setting the limiting elements of barnacles. Since barnacles or any species on that issue can't make do outside its tolerance limits. In this manner, it is estimated that the number of barnacles will decay as they scatter or total in spots where the environmental conditions of these factors become outside of its tolerance range. The number of barnacles is congregated in the sublittoral zone and in the intertidal zone, not very much affected by the temperature due to its high heat tolerance, abundant when the dissolved oxygen concentration is increased, in the pH level of 4.0 to 6.5, and in places where algae abound. Furthermore, barnacles will elude areas where competition is present. There were two sessions conducted over 2 days in Point Arkwright Rocky Shore, one in the afternoon and one in the morning. The exact location was randomly picked. The aim of the investigation is to find the effects of temperature, dissolved oxygen concentration, pH levels, competition, and food source on the distribution of barnacles. The materials used were notebook, pen, pencil, camera, iPad, phone, quadrats, tape measure, temperature probe, salinity probe, pH probe, dissolved oxygen probe. Procedures: 1. Randomly selected a place to do an experiment on. 2. Lay the tape measure out, starting from the low tide mark. 3. Alternately lay the quadrats down on both sides of transect. 4. Counted the barnacles inside the quadrat. 5. Took photos. 6. The temperature was measured in the rock pools around the transect using a temperature probe. 7. The dissolved oxygen concentration was measured using a dissolved oxygen probe. 8. The pH levels of the rock pools were measured using a pH probe. 9. All of the gathered data were recorded in a notebook. 10. All the steps were repeated many more times to gather more data. The abundance of Cirripedia on the rocky shore shows variance based on the distance from the low tide mark. An accumulation of barnacles is displayed about 2 to 12 meters from the low tide mark. The R-squared value of the trend line indicates a correlation between the distance and the number of barnacles. The rock pools that surrounded the transit lines were measured for the abiotic factors. It should also be noted that the experiments were conducted at different times. Furthermore, it was observed that no barnacles was fully submerged on the rock pools. Another point to be considered is that it rained lightly on both sessions of the investigation. With an R-squared value of 0.0528, the data gathered suggests that there is no strong correlation between the abundance of barnacles and temperature using a linear trend line. Note that some rock pools were shaded from direct sunlight. The graph shows a very small correlation between the percentage of barnacles present and dissolved oxygen concentration. Some rock pools were observed to have abundant algae. The data points show that the observed Cirripedia congregated in the pH levels around 8.6 to 9.1. The graph of the abundance percentage of barnacles against the distance from the low tide mark shows varied data points, but nonetheless with a significant correlation between variables. This indicates that the presence of Cirripedia will decline as the distance from the low tide mark increases. The trend line also shows a concave down parabolic graphs which suggests that the abundance of barnacles also declines when water depth increases. This supports the hypothesis and literature which says that the barnacle are mostly found in the sublittoral zone, 75%, and the middle level of intertidal zone, 25% of the rocky shore. The scattered data on barnacles' abundance against temperature and its very low R-squared value suggests that there is no correlation using a linear trend line. However, the trend indicates a positive relationship between the temperature and distribution of barnacles. This means that as the temperature increases, the number of barnacles also increases. This agrees with the research stating that the barnacles have quite strong tolerance to heat and thus supports the hypothesis. Since barnacles need water to get oxygen, it would have to be in shallow waters or near rock pools. This is supported by the graphs of the abundance of barnacles against dissolved oxygen concentration, which shows that as the dissolved oxygen concentration increases, so will the presence of barnacles found be. The lower R-squared value could be explained by the abundance of algae present in some of the rock pools, which means that more barnacles accumulated in these areas. Moreover, none of the barnacles was fully submerged in the water due to the presence of whelks submerged in the rock pools. This supports what Fairweather and Branch reported about whelks being one of the main predators of barnacles. Acidity and pH levels have an inverse relationship. Therefore, high pH levels would have a very low acidity. The results showed an increased number of Cirripedia in a very low acidity of pH level to approximately 8.6 to 9.1, which was quite deviated from the optimum pH levels of 4.0 to 6.5. This might be due to the light shower of rain in the two sessions which most likely made the water in the rock pools more alkaline. Nevertheless, since the literature stated that it is the optimal range for the pH level, not the tolerance range, the data on the graph is still valid. Furthermore, as Nardone reported, reduced pH can cause a more readily cracked base plate. Therefore, it is not surprising that barnacles have more abundant in areas of high pH levels. Okay. There were several limitations in the method and procedure, such as the random selection of the exact places where the investigation was conducted. Random selection, for example, random number regeneration, would have ensured that the result of the investigation is accurate, representative, relative to the world's rocky shores. And since the exact location was picked based on the presence of barnacles, the data gathered may therefore be not of the most accurate representative finding for the rocky shore. There are also systematic errors present that threats the validity of the findings. One source of systematic error would be imperfect observation methods. The data collected are not accurate and no technological instruments were used to find the best estimation. Another source would be the imperfect calibration of measurement instruments. This species of equipment used might not be quite accurate, with these variances for the same type of probe used. Furthermore, the methods and procedures overall might have disturbed the norm of the Cirripedia. Despite these limitations, the measurement process was consistent throughout the investigation. The data collected were sufficient enough to agree with the literature and support the hypothesis. This validates the findings of the investigation.
Maliit ka.
For future similar experiments, it is advised that more sessions should be added in order to have more data collected since more data would improve the validity of the results. Another improvement would be using a piece of more sensitive equipment for more accuracy. This will lessen the probability of systematic error being present and thus lessen the threats of the result's validity. Additionally, increasing the randomization would help in justifying the measurement process. Overall, the biotic and abiotic factors, temperature, dissolved oxygen concentration, pH levels, contributed to Serpedia's limiting factors, which is crucial to the organism's niche. The number of barnacles is congregated in the sublateral zone and the intertidal zone, not very much affected by the temperature due to its high heat tolerance, abundant when the dissolved oxygen concentration is increased and where there are plenty of algae. Surprisingly, the aggregation of barnacles was observed higher than the optimal range of the pH levels, which was very likely due to the light rain.